Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving deep into running the massive DeepSeek R1 model on personal hardware, thanks to some amazing advancements. It's mind-blowing.
Absolutely. I've been following this development closely. The fact that we can even consider running a 671B parameter model on a consumer machine is incredible. What's the secret sauce?
The magic is a combination of factors. Unsloth AI's dynamic 1.58-bit quantization is key. They've compressed the model down to a surprisingly manageable 131 gigabytes, making it feasible for many. And then, Llama.cpp provides the engine to run it all.
So it's not just about the model size reduction, it's also about the efficiency of Llama.cpp, right? It's like a perfectly tuned engine for these compressed models.
Precisely. Llama.cpp is the workhorse here, allowing us to leverage the power of our CPUs and GPUs, even if they aren't top of the line. The tutorial walks you through installing Llama.cpp, either by downloading pre-built binaries or compiling it yourself. A bit of a choice there, depending on your comfort level.
And then, the model download. Hugging Face is the go-to place, right? They're hosting the quantized version of DeepSeek R1.
Exactly. They provide the 1.58-bit version, which is the one we're focusing on. The tutorial even gives you a handy Python snippet to download it programmatically. No manual clicking required.
But, I'm a bit concerned about the path management. It seems like keeping track of the directory structure is crucial.
You're absolutely right. That's a very important point. The tutorial emphasizes knowing your working directory. The model files download into a subfolder, and you need to specify the correct path when you run the Llama.cpp server. One wrong character, and it all falls apart.
I see. So after downloading and installing everything, we fire up the Llama.cpp server. That's where the real magic happens, right? It creates a local OpenAI-compatible API.
Yes. You run the Llama server binary, pointing it to the downloaded gguf files. There are several parameters you can tweak, like context size and the number of GPU layers to use. The tutorial provides excellent guidance on customizing these based on your hardware.
And then, the final step is connecting this server to Open WebUI. That's where we get the user interface, right? It's all about making it user-friendly.
Exactly. You add a new connection in Open WebUI's admin settings, pointing it to the Llama.cpp server's local API endpoint. No API key is needed, which is pretty cool. Then, you can start chatting with DeepSeek R1 directly through the Open WebUI interface.
This is amazing. But the tutorial mentions that performance will be slow, even on a powerful machine like the M4 Max. Is that a deal breaker?
It's a realistic expectation. We're talking about a massive model running on consumer-grade hardware. It's not going to be blazing fast, but the fact that it works at all is a huge achievement. It opens up possibilities for researchers and enthusiasts who don't have access to massive server farms.
I agree. It's a testament to the advancements in model compression and efficient inference engines. It's a significant step forward for open-source AI.
Absolutely. A huge thanks to Unsloth AI and the Llama.cpp community for making this possible. This is a game-changer for accessibility in AI research. Happy experimenting, everyone. And that's all the time we have for today's Tech Bytes and News. Thanks for listening, and goodbye.
Bye-bye.